Hi, this is Rachel Fiore, and I'm going to be talking about the third grade science Georgia Standards of Excellence. So one of the things I noticed right away when doing this is that all of a sudden we're talking about a lot more vocabulary compared to kindergarten, first and second grade. So I don't anticipate that it will be easy to listen to this entire thing in one sitting. So I recommend that you just do it in chunks. So we're going to start with the overview, and the basic content in third grade is rocks and soils, fossils, heat, plants and animals specifically within geographical regions of Georgia, and pollution. So the first standard is about rocks and soils, and some big things here are some clarification statements. So for example, cleavage, streak, and classification of rocks is not studied in third grade, but these things are color, texture, luster, and hardness is studied by the Mohs scale. Now I'm going to talk about this in a little bit, but we'll start with color, texture, and luster. So color, there are many, rocks come in many different colors, and you can just look at them and describe them as green, black, gray, brown, pink. And then texture, some rocks are smooth, but have these kind of edgy bumps. Some are bumpy, like kind of like sandpaper. They feel like sandpaper. So there's rough, smooth, large bumps, small bumps, and then luster, shininess. So this is a shiny, kind of large, bumpy, smooth, black rock. So that's what they're looking for with 8-year-olds. They want to be able to use this color, texture, luster. And then hardness is, oh, and also just to show you some pictures of granite, I just pulled this from a kitchen store. I mean, this is why people like granite, because granite shows you really well, can be very, very beautiful and also come in many different colors. So this is a nice just, illustration of how the different colors like rocks can come in. Granite is a type of rock. So here's another illustration of some of the textures you might see. These are some classic rocks. If you have any rock kits in your school, you have these rocks. So pumice is that kind of, it's one of the rocks that floats, but we can just see there's different versions of bumpiness and different versions of the kind of the smoothness. So this is smooth, and this is smooth, but this is a soft smooth, and this is kind of a hard smooth. And even within the bumpiness, we can see different kinds of bumpiness. And then luster and shininess. So you'll know a rock is shiny. If it's shiny, then it has luster, and if it doesn't shine, it doesn't have luster. Now I'm going to talk a little bit about minerals, because if you go back and read the standard, it doesn't say minerals, which is that's a change. And the weird thing for me personally is they talk about Mohs test as for test for hardness, but Mohs test is for minerals. So you wouldn't really do a Mohs test on a rock. So what I'm thinking is that you can still embed minerals if you want to. It would still be within the standard to do something about minerals. So I think that's just the key to understanding minerals is that minerals can exist on their own or as part of rocks. And that's basically it. The other flip side is that when you look at a rock, it's made of one or more minerals. So for example, granite, which is my favorite rock to study because it's such a big deal in Georgia. We have a lot of it. We've mined it. We've sent it all over the world. And the mineral, so the rock is made, if we think of ingredients, is made of mica and feldspar and quartz. Now these are all minerals. This happens to be a mineral with a lot of luster. And that's why you see kind of like shiny sparkles in granite. Now some granite is made of a different kind of mica. But in general, this concept that rocks are made of one or more minerals is really what you can go into, and then you could test some of these minerals on the Mohs test. So the Mohs hardness scale, notice that it's MOHS with no apostrophe. And basically, we're looking at right along here is where you would probably do something with third grade. So if it can scratch with a fingernail, that's called a soft rock. And that is really kind of an interesting concept, that we'd have a soft rock, which is different than a soft pillow, which is different than a soft voice. So in third grade, it might be nice to explore that, just the language of that, of what soft means and what the context, how the context decides what it means. If it can be not scratched with a fingernail, but a copper penny, it would fall right in here. And you're not going to do this one. You might do this nail one. So the idea is if it can be scratched, then the level at which is scratched tells you how soft, which is down here, or hard the rock is. The other way you can do it is to scratch them against each other, and the one that scratches or gets scratched, this gets scratched one, is the softer rock. So I really like the softer mineral, I'm sorry. So I really like the mineral talc. It's probably in your kit. If not, it's pretty cheap to buy. Anyway, it has just a really cool feeling. It's very slippery and soapy, and it's the softest mineral, so you can scratch it with your fingernail. So it's kind of, if you're looking for like a little hook, this is a really nice mineral to show the students and let them feel. So that's basically it in the sense of, if we're thinking about rocks, we're really looking at, just to follow the standard, is color, luster, texture, and hardness. And the things that we leave out are things like how the rocks are formed, the rock cycle, and anything like cleavage or streak test. So that's the boundaries of the standard as they are now. So the next thing to talk about is soil. And here we're talking again color, texture, and these are some of the physical characteristics, the ability to retain water, and the ability to support growth of plants. Now these two, retaining water and supporting growth of plants, are pretty related, and I'll show you in just a second. And then there are 3 identifiable types of soil that they want students to know about: sand, clay, and loam. So about colors, soil is definitely different colors, and you can go out in your backyard and you can find it, especially if you go ahead and you just dig deep down, you're going to see that the soil is different colors. And depending on what rocks it was made from, what level it's at, where it is in the country, we have this Georgia red clay, which I'll talk a little bit about. But anyhow, you can go outside and you can easily find that soil is different colors. Now, one of the things that I personally didn't know, and it was kind of interesting to me, is that I didn't really know that the first kind of soil is actually sand. So sand is soil, and it's the kind of the most biggest particle size soil. So if we go ahead and we think about rocks and they're getting smaller and broken down, and they might be called pebbles or little stones or anything like that, but there's a certain point, and soil, more than anything else, is decided by its particle size. So like as big as these little pieces are, there's like a little fish in there, but if they're as big as these little pieces are, when they reach a certain level, they're called soil, and that soil is sand. If the rock pieces are bigger than that, it's still a version of a rock. But at this particle size, this size of this little pieces here, this is called soil, and that's what defines soil. It's how big those pieces are. So basically, if we talk about rocks, they break down, and then we get to this point where they're considered soil. And then, of course, they can keep breaking down, and they break down into some other components. One of them, which is in 3rd grade a year ago, or sorry, with the GPS, was silt. So when sand is broken down, it gets into smaller and smaller kind of pieces, and those pieces have names. And one of the pieces in between sand and clay, which is the one that's actually identified in the standard, is silt. But the key is with soil is just it gets broken down into smaller and smaller pieces, and sand is kind of the biggest pieces of soil. And then when the rocks are broken down to even the smallest pieces that can exist, it's called clay. And clay are the little tiny, tiny, tiny pieces, and we're famous for our clay. So the thing about clay is the pieces are so small, they kind of glom together. And that's why sand, which lets water go through too fast, remember they talked about what kind of soil is good for plants. Sand lets water go through too fast. That's why you don't see things growing on the beach, right? And clay doesn't let water go through fast enough. So here is a very classic Georgia look, which is you have that construction site, you see those layers, all that Georgia red clay, the soil, when the water comes down, it just sits there. So it's because the pieces are so small, they're kind of so close together that the water can't get through. So then the other word that they have in the standard is loam. And so that's basically, I have the word silt, but you can just say that if you mix up different particle sizes of soil, if you take out sand and clay and all the different kind of things in between, you mix it with a little bit of organic material, it's called loam. And I don't know if you definitely need to define loam as specifically having organic matter, but just this idea that we have this mixture of sand and clay and just smaller little particles. But the key to it is it's got enough space in between it that you can have water and air, and that's really important for plants, even at the root level. So it has to have enough space for the roots to kind of move through, but not so much space that the water can't be held in. So that's loam. And so the key with loam is it's your best soil for planting. It's going to be your topsoil. And the thing about topsoil is there's not really as much soil as you think. This is kind of, I saw this analogy once, I thought it was great, which is basically if we think of the earth as an apple, that little tiny bit there is kind of your usable soil. And soil is, we're talking about in this kind of standard about natural resources or pollution in general, we can think of soil as a resource that we want to protect. And it takes a long time to make soil. It takes about 1,000 years to make an inch of soil, like good soil, the soil that's going to grow things. It's going to have the right amount of moisture and air and nutrients in order to be good for growing plants. So that's everything about A and B. And the last part is about water and wind to soil and rocks. Now I've talked about this a little bit, and you can just, the key to it is having students look around their school or their home and look at for evidence of water and wind. And so a classic one would be if you had a big flood and you saw like a lot of the soil had kind of washed down. So that's kind of what they're looking for. It's a smaller version of erosion, but you can talk about different things. But the key is that wind and water break down rocks and soils into smaller pieces. So if that wind is kind of blowing against, especially if it's blowing sand against things, then we can go ahead and that can break down the rocks into smaller and smaller pieces. Or water falling on things can break down things into smaller and smaller pieces. So it's kind of, they want you to do that, but at more of the local level and not specifically talking about words like weathering. And this next section is fossils. Again, like I said, this is going to be a very long audio, but this next section is fossils. And again, the types of fossils are not addressed in this standard, but basically the idea of how things become fossilized, which is kind of funny because they can become fossilized in different ways, but I'm going to try to describe it kind of generically. And the other thing is about just evidence of past organisms and the environment. So I don't think there's a big emphasis on fossils, just more that they exist and that the animals or plants that they learn about, they may not exist on Earth at this time, but they listed on Earth before our time. So here's some kind of key understanding about fossils. Most things that die don't become fossils. They're not found everywhere. And they're actually found in rocks, but only some kinds of rocks. And without giving, so it's a little bit tricky if you want to talk about where fossils are found, but you haven't told about how rocks are formed, it's a little bit tricky. But if you just talk to them about the fact that they grow in the softer rocks, the fossils are found in the softer rocks. So the ones that you can scratch with your finger specifically, and I'll name them sandstone and limestone would be the classic ones where you would find fossils. The idea is that you find fossils in rocks, but only rocks with certain characteristics. Other thing is that we don't know every single thing that existed. There are gaps where we don't have information, and we can't exactly say how things are related to each other. And another thing is that dinosaurs aren't the only things that make fossils. In fact, there are fossils of both and other animals and plants. I don't think students always know that plants also make fossils. So here's kind of a generic way that fossils are formed. So basically we have something that dies, and what happens when it dies is it gets quickly covered with sediment. That's the key, is it gets quickly covered with sediment. If something happened, and things die all the time, and so basically in the wild they decay or are eaten and they don't become fossils. But if there's just kind of like a landslide or something where it gets decayed for a long period of time, it gets covered very, very rapidly, and then it's in this soil for a long period of time, eventually that soil becomes rock and it gets more down into these layers, and as it becomes rock, it can become fossil. So what happens is the soil, as it's becoming rock, parts of that go into either the bones or some of the other parts of the animal and make that what was bone, turn it into rock. And so that's what happens. It's a little bit hard to explain without using specific words, but basically the idea is that it's covered rapidly, and then the bones, or it could be something like a footprint that's filled in, and as it's filled in rapidly, that soil over time becomes rock, and that makes it so it doesn't decay. So I encourage you to look, if that didn't make too much sense, it was too vague, to go and look yourself about fossils, but this is kind of, this picture is actually a really, really nice one. So just so you know, fossils aren't only found in kind of weird places that we've never gone to or only in other continents. They're actually found here and they've been found in Georgia. So this is some cool fossils. I got this from a friend of mine, and these are some sloths and stuff that have been found in Georgia. So, and then this is a big, I'm not really sure what it is, some kind of reptile. Anyway, it's pretty cool that we have big fossils in Georgia. I thought that would be really nice to tell kids.